You're listening to the Neurocareers podcast with Dr. K. Episode number 8.
Dear listeners, we are continuing our exploration of neuroscience and neurotechnologies and careers in these exciting fields. Today, our guest is Professor Elvira Brattico, an expert in neuroscience of music. Welcome, Professor Brattico. Can you introduce yourself and tell where are you talking to us from? People are joining us from all over the world, so it gives a nice sense of where you are when you are describing your place.
Well, thanks so much, Milena, for inviting me to this podcast. I'm really also excited to talk to you all. And I'm talking from southern Italy at the moment. The place is Bari. It's the heel of the Italian boot. And I'm here because I have a part-time position as full professor of experimental psychology at the local University of Bari, Aldo Moro. But my main position is actually in Denmark. So that's where I do my main research work. So I am also professor of neuroscience, music, and aesthetics at Aarhus University. And I'm one of the PIs of the Center for Music in the Brain, which is a center of excellence funding since June 2015 by the Danish National Research Foundation. It's the main sort of government funding agency providing generous funding for centers of excellence, and we are one of those. And we focus on basically utilizing neuroimaging methodologies on humans for studying how our brain can process, predicts, and understands and be moved by music and musical sounds all over the world, actually. So we are working with also both Westerners and non-Westerners listeners. And maybe we will even work with animals at some point, because we recently hired a professor who is actually expert on prerequisites of musical communication in vocal learner species such as seals, for example.
Oh.
So this is just the future.
That's exciting. So you already predicted some future maybe of our new podcasts when you can come and talk about those projects. It sounds very exciting. Thank you. Thank you for your introduction, Elvira. Now we are exploring possibilities of doing brain-related research for people coming from different types of background. And I think you are a perfect example of that. I would like to start with this, with your initial background. As I remember, you were getting degree in philosophy. Is that correct? And then you decided somehow to connect it with the brain. So tell us about this, please.
Oh, that's wonderful. You have such a good memory. But yeah, you're right. So I did study philosophy as a master's student in Italy, in the same university where I am a professor now. And when I was studying the philosophy, I was also sort of very interested in, of course, methodology of research, philosophy of science, mathematical logic, and psychology. So I did study a bit more than required, and then I accumulated some knowledge. And when I finished, I realized that I want to move to empirical sciences and to understand more about how the brain works, inspired by the work I did for my thesis. For the thesis, I studied the tone sensation theory by Hermann von Helmholtz, viewed from a cognitive psychology perspective. So it was very interdisciplinary thesis for my master's degree, where I looked at the work of like old sort of scientist from the past. So he was from the late 19th century, and he was himself eclectic scientist. So he was a physicist, physiologist, philosopher, and he was actually a figure who inspired me very much. And he was interested in bridging art and science, and so understanding the basis of music perception using physical laws. And it was a new endeavor back then. Like in my thesis, I tried to search for the seeds of the ideas that are in the music psychology, modern music psychology, and to search those seeds in the work by Helmholtz. And so that's how I sort of started. And the reason why I chose this topic was that I was a musician myself, of course. So I did have another diploma. I mean, now it's actually corresponding to another master's degree in piano performance. And so I had studied also music from theoretical point of view, and sound composition, harmony theory, and so on and so forth. And so when I had the opportunity for my master's thesis to combine my passion for music with passion for philosophy and science and psychology, then I put everything together. So I did this kind of, it was a thesis which was done in the libraries, looking for new books written by psychologists around the world, but also old books from the 19th century, which I dig, written in German, and I was digging them from some libraries in Roma and other places in Italy. So that's how I started. And then I met, while doing this research, I met with Mari Tervaniemi, who is currently professor still at the University of Helsinki. I met her at a conference in Roma. And I think, I was still a student back then, master's thesis student. And then she heard what I was doing, and she was nice and, welcoming me and supportive. So this kind of meeting was actually important for me, because when I heard that it was possible to get money to travel abroad and do what I liked the most, which was studying. So that was like a dream come true. I applied for these grants to specialize abroad. And I asked Mari Tervaniemi a letter of invitation. And so she kindly provided this letter. And with that letter, I applied to several places and I got 2 grants. And that's why I went to Helsinki. And then being in Helsinki, I had the opportunity to do empirical work, what I was fascinated with, to study music perception and follow the steps of Hermann von Helmholtz and do this kind of empirical research on music perception using electroencephalography. Thanks to this grant, I went to Helsinki and I started to do this one experiment with EEG electroencephalography with real people and real experiments. It was very exciting for me because I never did it. So it was totally new experience. I had to learn by doing. And this took me some years, of course. So I worked as a research assistant in the beginning at the Cognitive Brain Research Unit at the University of Helsinki, until I realized or I got convinced myself that I could do a PhD. So after 3 years or 4 years that I was already working in the lab for acquiring the skills that are needed, which I didn't have yet, then I got brave and I got money to enter a graduate school. And so I did apply and I would pursue my PhD in psychology. And for that, because I had this weird background, I had to study more. So I had to get, I think it was 30 credits more than fellow students who had a degree in psychology. So I had to demonstrate that I had the basics psychology degree. And then I had to produce the scientific papers which had to be published. Back then, the requirements were pretty tough in Helsinki. So my PhD thesis was finished end of 2006. So it's some years ago. We had some requirements of having already published, I think it was 5 papers. So it's quite many. And I had actually more for the thesis. I think I had 7, if I remember right. It was really very nice, a bit tortuous, complicated path, but it was really interdisciplinary, as you guessed. And so I really thank you for this question because it allows me to go back in time.
Yes, we can travel in time here. Absolutely. Back and forth. In our previous podcast, our guest said that probably the only impossible thing in the world is to travel in time. Everything else is possible, but I'm convinced that it's possible to travel in time, and we can do it in different ways, and using our memory, and even studying history, studying languages. Like you said, reading people who inspired you. We are looking into the past. We're traveling when we're connecting through music, through different literature sources. I think that's possible.
I agree.
You were switching from theoretical work to this experimental. What were the main challenges? You needed to start registering electrical activity of the brain and analyze it. So it was very different from what you used to. What were the main difficulties and what helped you to overcome them?
This is also a very nice question because if I think back again in time, I think that what was most difficult was actually being confident about what I was doing. Because when you have like the specialized background, somebody has given you a strict direction, so it's a bit easier to navigate through the things that you have to do. But when you have to learn it almost by yourself, then you have to go a bit more by trials and errors, and you have to find your way. And of course, you have the supervisors of your work that tell you things. But when you are not too confident, then you don't want to ask. In fact, this was really a problem for me at the beginning, that I didn't want to ask because I thought that I should know everything. I was convinced that I was the only one not knowing things. And because I had this more humanistic background, so I tried always to do by myself and to solve things by myself, which in a way sort of forged me. So it made me resilient and motivated. But I think I also wasted some time and made maybe some mistake, which I wouldn't have made otherwise. And I remember that it was very revealing after, maybe the second or third year that I was doing this type of work, when I realized that other fellow students who had the sort of right degree, as I thought it was, they actually did not know exactly the same thing as me. So I was surprised, and I was assuming too many things. I was assuming knowledge that actually others also did not have yet. Because in fact, when you study psychology, you might not know about EEG. You not necessarily worked with EEG, for example. You don't necessarily have the anatomical terminology or concepts from your studies. And the other way around, when you study biology, you are not necessarily very well prepared for psychology, paradigms or other things. So for me, I was assuming that everybody else knew better except me, but it was not exactly like that. I think that was one big difficulty. And of course, statistics was a bit problematic, but I had read, of course, and I studied it myself. And then I think I know enough now, or I very quickly actually got enough understanding, and I was able to, write and do the analysis myself almost at the beginning. I think actually my sort of background, my path, is what is now very much in fashion in university pedagogy. So learning by doing or research-based teaching. So I was really learning things that I needed for my research, and I was applying immediately the concepts that I learned because I had to use those concepts and those tools for my studies. Now, of course, after many years, like maybe 20 years from those, or more than 20 years, sorry. So I have actually this role as a supervisor myself of bachelor's, master's, and PhD thesis, and I've done it now for quite a while. And I can say, especially when you see the younger students, that they are not able to apply what they've learned theoretically, and it's sometimes really the gap is very huge. So I think that even if it was quite troublesome back in those days to learn by doing, I think that it's actually a very good way to learn, especially if you have close tutor, so that can help you when you encounter some mishaps.
So you are applying this experience that you had, this learning by doing now with your students when you are mentoring them. Is that correct?
Yes. When I have, I do give, of course, some guidance and some directions, but I ask students to try themselves and to find themselves the solutions, of course. And this I try to do when possible, even with bachelor students. But of course, when you have bachelor students and you have hundreds of them, then you have more limited time. And in Italy, where I teach, there is not a tutoring program as in other universities, where there are tutors following more closely the students. So it's the professor can't handle it's not really possible to provide hands-on sessions to all the students necessarily, but in some cases, for one of the courses that I've been teaching, I've done this, but not for other courses. It depends.
Thank you, Elvira. Another question that I want to ask is the following. People are taking different approaches to research. Some people master certain technique, let's say magnetoencephalography, and they think, okay, where we can apply maybe to this disorder, this dysfunction, to answer another question. From what I can see, you are using completely different approach. You have a question, let's say, how the music affects the brain. And you are finding various ways to investigate that question. What approaches have you used so far to answer this question? And what different perspectives or different angles does this approach provide you with to answer this question?
Yes, you're right, because I have actually been quite eclectic again in how I've used brain research methodologies. And yes, I started from the question. So when in the beginning, when I started my work as a student in Helsinki, I learned electroencephalography because that was the simplest thing to learn. And it's the technique that I actually encouraged my PhD students to learn first, or even master students, because it's sort of a quite flexible and really it's quite intuitive in a way. And also the analysis is not too complex, so you can start from there and understand the basics of also signal processing and some basics of programming, and then you can move to something more complicated. So after EEG, it was a bit the other way around. Where and how I can use EEG. So it was like starting from the methodology and then going to the question where it makes sense. But then I focused more and more into research about how musical sounds are processed by the brain and how they are remembered, for example. How our memory for sounds work. And I was more interested also in the neural substrates. And for that, I wanted to learn magnetoencephalography combined with magnetic resonance imaging, because this method, it captures the magnetic fields coming from the tiny currents flowing in the brain in a quite focal way. So it's very precise, and you can understand where the signal comes from in the brain. And then you can also go deeper in understanding what are the substrates of the brain structures that are helping you forming these memories and the predictions for sounds. And so this was the next step. And then the third step was that once I understand how we create expectations for music, I wanted also to understand how from these expectations and how from these immediate neural reactions to sounds, how we get emotions. So how do we go from the sensation to something that can be even mimic a feeling? So because we know that musical sounds can induce emotions, and we use music every day to regulate our mood and think back at our lover, or think back at good times, or cheer up or relax, and so on and so forth. So it's this kind of emotion and mood regulation function of music is very spread, universal, and it's probably even a reason why music existed in the first place in the Homo sapiens species. And in order to understand this, you have to go deeper in the brain. So you have to look into those brain structures that MEG is not so good in showing up, because the signal sort of is dampened very quickly out of the source. So for this reason, I decided that I want to learn functional magnetic resonance imaging, fMRI, and then I could design a study focusing on understanding how music that is liked is processed and which structures of the brain process favorite music, the music that is dearest to us, as compared to music that is representing and expressing different types of emotions, such as happiness or sadness. So I did this one study on music, sort of aesthetic and emotional responses, and using fMRI, and then other studies as well later on. So after this, I discovered even imaging genetics, because I got interested in going even deeper. So not only the understanding, the different brain responses and the neural structures where they are produced, and but also possibly the molecular mechanisms that might be governing this, or at least modulating these neural responses. So I learned that it's possible to combine genetic mapping with brain imaging methodologies. I went to learn this as well. So I learned in a lab, actually, in Italy, in the city where I am now, because there is a researcher, Alessandro Bertolino, who has worked in the Bethesda, the National Institute of Mental Health. He has worked and still works with one of the leaders in schizophrenia genetics. So I learned the methodologies back then, in 2010, and I applied it for some studies. I have now a few studies combining candidate genes, some mutations in some specific functional genes, with brain responses recorded either with fMRI or even with MEG. The final thing I can say is that, of course, more recently, we want to move away from the mapping functions to specific brain regions, but we want to look at the dynamic picture. So how different brain regions communicate. So how the signal travels between different parts of the brain and how these circuits are shaping in order to produce a specific behavior. So then I have been collaborating with researchers who are experts in connectomics. And so working especially with functional connectivity measures, but also with effective connectivity measures, in particular dynamic causal modeling. And more recently, I have some studies with methodology that allows to study the dynamic functional connectivity, how there is a phase locking between brain regions and what kind of patterns are most recurrent during, for example, resting state session or during listening to music or while trying to remember sounds, musical sounds. And this is interesting because I believe that in order to understand how auditory memory works, we need to understand how the brain circuits reshape themselves and then how they sort of by their reshaping and their patterns of communication, how they preserve and store some memories, some models of sounds, and so how they can then predict the future sounds as well. So it is not just engram that is located in one ear and stays there forever, but it's really like the engram, the memory for the trace for sounds is how it moves around, how it is traveling between brain regions. And this happens a lot during sleep. So the next thing I want to do is to actually study sleep. I've written and there was even some little bit funding that I obtained in collaboration to study this, but we are still starting this research. I also obtained as funding was for studying memory in dementia. So that is a new also study. So trying on one end, it's important to understand how memory for sounds work in healthy people, but of course, how it sort of disintegrates when there is Alzheimer, for example. So that is the next study line.
You already answered one of my questions because I usually ask, what are your future plans? So you already told us about this. Through all this work, starting with sensory processing, then you investigated formation of memory, then you were already going into the molecular level. Now connectivity between different regions. Now you're looking what's happening in sleep, how memory decays in patients. It's really a very broad research that you are conducting. Through all this research, what was the most unexpected finding for you that surprised you the most?
Yeah. I have to go back in the past because this we didn't expect back then. And it was the finding about music participants, these people who have a music-specific deficit. And we're trying to understand where this deficit comes from in the brain, because if you look at their anatomical images, they look very normal. So there's something wrong in terms of neural communications between brain regions, or how the signal travels between brain regions in relation to only to musical sounds, because they have no other problem with other sounds or any other cognitive ability. These are the people who are totally hopeless. They can't recognize even happy birthday if there are no lyrics. So the sounds are mysterious to them, musical sounds. they have normal language otherwise. Oh, yeah, except some possibly difficulties. But anyway, the thing is that back then we measured their EEG and we were looking for abnormalities in their EEG responses to sounds. And what was surprising was that they were normal at the level of auditory cortex, which is already starts to be already sort of cognitive process there, so that they could encode and have some basic sensory memory of sounds. But what they had weird was the brain responses related to conscious awareness of mistakes in the sounds. So we did also some source reconstruction, and then we found that the problems were out of the auditive, but they were more related to prefrontal areas. And this was surprising because I was sure that they would have some problems there. And this was the first study which was published. We had two studies actually, one published in Annals of Neurology and the other one published in Brain. We had hard times to convince the reviewers because they really wanted to see the data from every single participant to believe. And it was risky because we were saying things which were surprising, as you said. But the time gave credit to us because these findings were replicated also with other methodology and also with for example, DTI and several other studies showed the same thing other times. Yeah, it's maybe the most striking that I remember. I would say that there are other studies where you don't quite get what you expect, so that but it's rather like a disappointment. Or that, and then those studies were sort of a textbook finding, so that you have exactly the hypothesis is confirmed, the alternative hypothesis, and it's very clear and so on and so forth. So now I should remember another study too. If I look at children, I didn't mention that I've also started to get interested in children a bit because I had children, so we want to see how music develops, especially how they become so sensitive, because you can see that when they are 10, 11, they sort of lighten up to music. The musical interest sort of explodes when they're in the puberty period, basically. So I started to study also children, especially pre-adolescents, so when just initial puberty phase, because it's a moment when something is happening kids' brain, so that music becomes important for their life. It starts to become very pleasurable. It starts to be important for self-identity. So they sort of identify with their idols, musical idols, and so on. But we don't really know what is happening in the brain in relation to this special source of pleasure, which is music. And so we had another study which was surprising. It's not yet published. We sent out the revision recently. So I don't know how much I can mention it. But the surprising thing is that we did this kind of a dynamic functional connectivity analysis on children's fMRI while the children were listening to pleasant music that they overall liked. And we compared these brain states while listening pleasant music to silence. And the surprising finding was that the only recurrent brain state which differentiated the music listening from rest, from listening to the noise of the scanner, was a brain state only in the orbitofrontal regions, only there. And it was really fascinating to me to observe because there are really clear findings we didn't expect because it's quite sophisticated method to use for analysis. And also you would have expected something related to auditory cortex, but no, it was only in this part of the brain which is related also to evaluation and reward and pleasure, at least to understanding that you are in the pleasurable and motivational experience. This was nice and surprising, I think. Just another example. I have others that came to my mind, but I don't want to keep you forever. Yeah.
Yeah, we can leave it for our future podcast.
Yeah.
Yes, absolutely. Very interesting findings and surprising findings. And what you mentioned about getting those surprising findings, when you are getting something that you didn't expect, that nobody yet confirmed, what does it take to be courageous enough to really go and publish it and submit it even for review? Because I know, even from my own experience working with people, some people don't dare to publish because they think maybe there is something wrong. And then other studies come which confirm. And then people are saying, oh, we should have published it. But it's too late. Yes. Then they're not first anymore. So what would be your advice to those who are hesitating and don't dare to go forward and make it published?
Yes. In fact, I would give the same advice that I was given by my supervisor back then, especially I think later when he was one who was giving this kind of important advice, which is that before publishing, you should run another study so that you are sure that what you are seeing is right. I mean, it's replicated in some ways at least. So, of course, it delays publication, but at the end of the day, running a study or running an experiment can be pretty fast. It's more like the thinking part. It can be very slow, and the writing part. Having a sort of a second data set that can be used for replicating and validating your approach can really speed up things at the end of the day. And this is one advice. But if you don't really want to do a new data collection just for this reason, another option is to explore intensively the data set. So conduct different kinds of statistical analysis. Of course, this is risky because you might actually end up finding different things every time you run a new analysis. And then it can also turn out into fishing for results, which is as bad as the previous item or previous instance. But at least you should have in mind from the beginning. I mean, if you have as a principle a kind of analysis that you apply an analysis to your data set that is first testing a hypothesis, but it's also sort of validating this hypothesis. So if this is planned from the beginning of the study, then you are not fishing or doing real things on your data. I feel that from the beginning, you have to be aware that you have to have a clear picture of the data and of the analysis you want to do, and you have to basically replicate your findings, either with your data set or with a new one that you might acquire along. Especially if you have this kind of very risky type of project. So when you are doing a study, sort of more groundbreaking or really risk, it's good to have this kind of strategy in mind from the beginning. So really from when you pre-register in the study or when you are thinking about it. That's how I tend to think.
Thank you. That's a very good advice. I'm sure many people will benefit from it. All this work you have done, I'm sure you are interested in some practical applications, because this is also what people want. How do we apply it in practice? What can we do with all these findings? How do you try to apply it in practice? And if you have any projects where you actually are looking for these very practical applications of your research.
Yeah, I think that this is really a good point. Indeed, we are conducting studies that have a practical application. And I would say that there are two types of applications. One is related to improving how we teach music at different levels. So it's related to education. And the other one is related to how we can use sounds and music in particular, but not only music, it can be other kinds of sounds for clinical applications. And for the first line, we have studies with children, I mentioned before, and we are studying, for example, now children in middle schools, and we are studying middle schools in Italy specialized for teaching musical instruments within a curriculum. We want to look into these schools because we want to see if this kind of music education inserted in the curriculum, if it's useful and if it helps kids for academic capacities and outcomes and also cognitive abilities and so on. We think that if we would find that music improves cognitive skills, this kind of music education instrument learning in the classes, so then we could help policymakers to keep this type of special schools alive or even increase public funding for these schools. This is one type. There is also another example. It's a study we conducted recently where we looked into how teachers can teach to play some musical pieces in the conservatory. So we basically looked into mental practice. So thinking of playing something and learning while thinking, reading the score and thinking about how you are playing as an additional tool for learning by heart and also for performance on the top of physical practice, because physical practice can be quite demanding and can even hurt the articulations and so on of a professional musician. So we studied also this, and then we did find that it's helpful to have mental practice along with physical practice for memory, for memorization of musical pieces. These are two examples of applying our research for education, specifically music education. And then the clinical applications, of course, there are plenty. They are very well known. Music therapy or neurology-based music therapy studies. But my research is now concentrated, as I mentioned, on dementia patients, particularly Alzheimer patients. So we want to offer and test a new kind of intervention. This is still starting, so I don't reveal more, but hopefully it's going to be useful. So if we have findings, it will be exciting because we will target Alzheimer patients who are already advanced, who are quite serious already. Because most of the interventions are with the early stage of Alzheimer. We want to look into the moderate advanced stage, because those are the patients who are most left alone or most, without motivation or without anything to do. So we want to help those patients. And then we also have a study which is ongoing now in the Italian hospital where we are looking into another kind of music intervention on comatose patients, patients with disorders of consciousness. And of course, for those patients, we are trying to do whatever we can to have signs of awakening. We will see, we don't know yet. So these are some examples of possible applications.
Very exciting. Finding connections also with the brain-computer interface research, because there is a trend to evaluate the state of consciousness by using more neuro-driven methods, not just behavioral scales for evaluation, and brain-computer interfaces are used for this. Maybe some combination would be very interesting to look at with music as a stimuli.
Yes, I will need to learn more about this. Interesting.
Elvira, I know that the process of doing research, it's not only doing the research, but looking for funding for research. And this is a kind of a constant process. From one project to another, you need to find funding, and it's not always easy. Sometimes you're getting, sometimes not. You don't have 100% certainty that you will get what you want. What motivates you through all these years? And I remember it wasn't easy when we were studying together. I remember you looking for funding, and I remember that uncertainty. And the same, was with me and with many other students. But what motivates you, no matter what? Still do research, still apply for funding, and not give up?
Well, at the moment, I'm in a stage of career that strong motivations comes from my collaborators, in particular the young researchers who are helping me and that I want to support. And I see that they are very talented, and I want to find the tooling for them. That's mainly the reason. I don't have any other. I should add maybe that other motivation might come from possibility to impact the community, going back to the societal impact. For example, I have joined some funding applications to Italian government for creating a national infrastructure for aging or for studying children again. And if this would happen, then we would have improvement also in the research infrastructure, and also the possibilities for the people here have better services in the future. That's another motivation for joining these big efforts. But I think that the main motivation is really like helping and supporting the young generation of researchers. Yes, and then the second one is to contribute to the community enrichment.
Looking into the future, let's say 20 years from now, where do you see this field of neuroscience of music?
Yeah, this is very interesting. I think that if we look first in the past, the field has progressed hand in hand with the development of overall the field of neuroscience. And I expect that in the future, the field of music neuroscience will rely more and more on big data and artificial intelligence type of tools, and it will more and more integrate with technological advances, maybe with the BCI as well, and all what we can use for example, allowing the machine to find the right sounds for us in the right moment according to our psychological state and neural state. And this could really be useful if you think about how much sounds have an impact on us. So we would avoid maybe in the future entering a shopping mall and being disturbed by the techno music if we totally disliked or hated. That would be a good advancement also. This is a joke. Overall, I think that it might go very much towards that direction, integrating more and more the technological advancements and analysis sophistication with the brain research for music.
In between of all your projects, all the work you do, what are your best ways to relax so that you then can gather all your energy to get to work again? And do you use music or playing music for this purpose?
Yes, of course. Yes, absolutely. And as the famous colleague Isabel Perez, she's professor from Canada, she wrote in a recent book that was published, she was inspired to start again playing the guitar, classical guitar in an orchestra, because of reading so many findings on how music can help for healthy aging. I have the same approach. So I know I read a lot and I know all the benefits of using music in daily life and also for neuropreservation. So I sort of force myself, of course, in all the hectic life we are running. It's not so easy to find moments, but I sort of force myself to find. And also I have children who are playing instruments, so I use this opportunity to join and to play myself whenever I can. And of course, using music in the sort of, functional way to modulate and regulate my mood. Yeah, definitely I apply my research in my daily life.
That's wonderful. What is your favorite music to listen? And what's your favorite music actually to play?
Oh, yes, well, they're almost correspondent. I like to listen. Well, I must say that it depends on how I want to affect myself with music. Like if I want to feel elated and upbeat, then I listen maybe to Latin or some more pop or Latin stuff that might even make me dance. But of course, I love classical music a lot. I'm a classical pianist by formation, and so I love all the classical composers, all of them. Some more, Beethoven, Mozart, and some more recent ones, Janacek, Scriabin, Rachmaninoff, all these famous composers. But for listening, I also do like some of the pianists like Ludovico Einaudi or some other pianists. It was relaxing, sort of almost new age type of music that I also appreciate a lot. Or soundtracks with piano in it. It's not about piano, I guess, but not only. So some other stuff too. And also some world music I do enjoy a lot. So listening to music from different parts of the world.
Our podcast is called Neurocareers, Doing the Impossible. When you were starting your neuroscience research, switching from philosophy to practical work to neuroscience, many things that now are already possible were impossible for you at that moment. What suggestions from that experience can you give to students, researchers who are just starting something new, how to make the impossible possible?
Yes, this is interesting also question. I love your questions, by the way.
Thank you.
I think that what I also try to teach to my children is to not to be discouraged if others tell you this you can't do, this is something that is not for you, it's not your way or your path. So not to listen too much. I mean, of course, it's good to listen to seniors, but it's also important to filter out those people who are just, even without knowing you or without having the right background to judge, that they tell you, no, this is not possible at all, and this is no way it's going to happen. Because in many cases, if I would have listened to these people, I would have never followed my dream. So I just sort of neglected I just went my own way. So I think that, and basically I think that if you find your diamond, your spirit, your force inside to try to follow that one. And take the advices from the people who are supporting and helping you to follow this. So I think that the first advice is to find what is your force, and then to follow that and filter out what the others are telling you, especially when they don't know anything about what they are saying.
Absolutely. It reminded me my conversation with Professor Lofty Zade, who was the originator of fuzzy logic. And fuzzy logic for many years was fairly controversial topic, and many people were critiquing it. And what Professor Zade told me, he said, remember this very important thing. When you are doing something and other people say, oh, it's impossible, smile, say thank you very much, and continue doing it.
Yes, that's extremely good advice.
Now, after all these years, I was presenting at the IEEE conference, and they had even a prize already at the name of Professor Zade. He is now internationally recognized fuzzy logic theory, is recognized, used practically in many countries. In Japan is one of the biggest one. So he won because he persevered.
Exactly. Yeah, I think that the perseverance is actually what distinguishes people who succeed and those who don't. People who persevere might even be less talented sometimes, but they really want to push forward one idea, one dream, one passion. I think that's really crucial.
Yeah, thank you very much for this advice. I think it's very, very valuable. If people who are listening to this podcast want to connect with you, maybe to establish collaboration or just ask questions or learn more about your research, can you tell how they can do it?
Yes, of course. I am in a different social media, first of all, in Twitter under my name, Facebook under my name, Elvira Brattico, and of course I have institutional email, elvira.brattico@clean.au.dk. And that's, I think, the best email address I can give, which is my official one.
Wonderful. We will add this into our podcast notes. And if somebody wants to get into this field of neuroscience of music, what would be like a primary source, the first one? Where would you suggest people to look?
Oh, yes. And actually, this I should have added before, because there is also possibility to contact me through our website, the Center for Music in the Brain. And this website is extremely good source of information for anybody who wants to start to understand what is this all about. The address is musicinthebrain altogether.au.dk. And from there, you can find the personnel and you can find me. I'm one of the professors there. And then importantly, you can find the links to our annual reports. The first one was from 2015, and now we are just releasing the latest one from 2021. And in each of the reports, you have articles about the research we are doing with some background. So there are short articles with nice figures, and they are really easy to read. They are thought for the general audience as well. And so it's a good way to start to familiarize with the field and our research. And they are all free. So you can just open the website, musicinthebrain.au.dk, and look for annual reports and then just download them.
Thank you so much. And I can confirm I looked at all the information on this website, and it's very exciting. And it's possible to look the projects about music in the brain. It's really, really good resource. I also highly recommend it to our listeners. Thank you very much, Elvira. It was a great pleasure speaking to you. It was very enjoyable, and I'm sure that our listeners will find this podcast very valuable. I wish you all possible success in all your future studies, experiments, and many new amazing, unexpected sometimes, but interesting discoveries. Thank you.
Thank you so much, Milena. Nice to talk to you as well. Thank you.